Hello Legacy students, Miss Marsh here. So what you're going to want to do today, we're going to writing a function rule. What you're going to want to have on you, a notebook, pencil, and then a calculator. Your learning goals for this particular video. I can write a function rule that represents a given situation. So you're going to want to grab that paper out I gave you in class. And this is going to look something like this. There's a few of them I kind of want you to kind of highlight or star, okay? So the ones that I really want you to kind of make sure you pay attention to is more than and less than, okay? Those ones are what I'm going to call the backtrackers, okay? Whenever you see these two kinds, they're going to flip-flop what is around them. So if you would see x less than 2, and you know less than is subtraction, so you would think it's x minus 2. But less than actually means you're going to be doing 2 minus x, because it says x less than 2. So 2 needs to be, you need to take x away from 2. Okay, so not that. You want this. Same for more than. You got to flip that business around. Okay, you're going to want to make sure that you don't lose these words or phrases. We're going to be using them in this video today. So let's take a look and actually translate some of this. So I have 5 minus a number, d, is 9. And I need to translate that to a rule or a function rule, okay? So 5 minus a number d is 9. So what I'm going to do is I'm going to start writing above here the translation that I can find. So 5 is just 5, right? Minus, if we look back, minus meant subtraction, right? And a number d. So they're basically giving you the variable they want to use. You want to use the variable d. Is. Now if we look for is in our thing, is equal. So I'm going to put an equal sign and a 9. So my answer, 5 minus d, equals 9. Not too bad, right? Now let's look at this next one. The product of 17 and a number is 10. So let's look at our list, and it looks like product is for multiplication. So I'm going to put a little note to myself. Multiply. Okay. And then I got 17. So I'm just going to put 17 and a number. Now, they don't tell me what number is. So we're just going to use some random variable. Let's just use x. And then is, we know that to be equal. So 10. Let's read our pseudo math. Multiply 17 and x, and that equals 10. So basically 17 times x equals 10, or 17x equals 10. Whichever one you want to write it as. Both of them will work perfectly. Let's try a few harder ones. So 11 minus the product of 3 and a number is 29. Let's translate just kind of like that pseudo math again. So we get 11 minus. We know minus is subtract, so I'm going to put a big subtraction sign. The product, multiplication. So let's multiply 3 and a number. So 3 and a number. Let's pick x again. Is 29. So equal 29. So 11 minus multiply 3 and x equals 29. Basically what we're going to translate that to is 11 minus 3 times x, or just 3x, equals 29. Not too bad, right? What about this one? 12 less than the quotient of 12 and a number is 52. So I got 12 less than. Remember, less than is one of those flip-flop ones. So we're going to do subtract, but then I think above that, we're going to go like this. So then we kind of remember to flip-flop the numbers around. Then they say the quotient of 12. Well, the quotient is a fancy word to say divide. So we know we're going to divide something. Let's find out what two somethings we're going to divide. Of 12 and a number. I'm going to use n this time, just to spice it up. So 12 and n is 52. Remember, is equal. So they tell me 12 subtract, and remember we're going to flip it around, divide 12 and n equals 52. So instead of doing 12 first, since it's a less than, I need to write this stuff first. So I'm going to divide 12 and n. Like that. And I'm going to subtract 12 from that, and that's going to equal 52. Not too bad, right? It's kind of like translating a foreign language into English. Or taking English and translating it to a foreign language. That's pretty much all we're doing. Let's try this one, writing a function rule. So I got a pizza place, and he charges $7 for a large pizza and 75 cents for each topping T on the pizza. What would be the function rule for the total cost of the pizza? C. So basically, you got to write the function, or in unfancy words, you got to write the equation, right? So I know that my C is my answer. Okay? So C has to equal, because that's the total cost. What would be the function for the total cost? So they're asking what C equals what. Okay? Now, what you're going to always want to do is put the first part that keeps on changing, or the per part, or for each something or other. So we know for each topping, we're going to pay 75 cents. We just don't know how many toppings we're going to put on this pizza. So I know for every topping, I'm going to pay 75 cents. So if I have, let's say, two toppings, I'm going to pay $1.50, right? So I did 75 cents times 2. So we're going to go 75 cents times T, because that's the changing amount. This is how much it's changing by each time. Okay? Then we're going to add on what is the straight up cost, just the normal thing that normally happens. Well, I'm going to pay $7 no matter if I just push cheese on it. It's going to be $7. So I'm just going to add $7 on, because that one doesn't change based on the number of toppings. I just need to pay $7 no matter what I put on my pizza. I'm paying $7 for my pizza. Let's try when we actually have to write and evaluate. So I have this concert seating plan that's shown right here, and reserve seating is totally sold out. The total revenue from ticket sales will depend on the number of general seating tickets sold. Write a function rule to represent the situation. What is the maximum possible total revenue? So I know that I have my total revenue, so I'm going to put a big R. Now I'm going to have a changing amount, right? And the changing amount is going to what I'm depending on. I'm depending on how many general seating I'm going to sell. Well, I look over here and I see that general seating is $10. It's worth $10. So for every general seating ticket, I'm going to get $10. So if I buy 3 general seating tickets, I'm going to get $30, right? So basically, we're going to go 10 times X. X being however many seating tickets I'm going to sell. Now, how are we going to find out the constant amount? Well, I said that reserve seating was completely sold out, right? So let's figure out how much money did we actually make off the reserve seating. So for $25 per row, or per seat, but notice I have 10 rows of 12 seats per row. So basically, I have 120 seats here to seat, right? Because 10 times 12. And for each one of those, I get 25 big ones. So I know that I'm going to get a total amount of $3,000 off of that amount. So that is my equation to find out, or my function rule to represent this situation. Now, what is the maximum possible total revenue? So they're asking, how much money can I make if I fill every single seat in this house? So let's find out, how many seats can I actually sell? So if I have 30 rows of 16 seats per row, I have a total of 480 general seating seats to fill. Yes? Because 30 times 16. They are asking, what if that is my X? So let's plug in 480 for my X. So 10 times 480 is 4,800. I'm going to add 3,000. So 4,800 plus 3,000 is $7,800. $7,800 is the maximum possible total revenue that I can make if I fill out every single one of my seats. Now, what about writing a nonlinear function rule? Here's an example of one. I can write a function rule for the area of a rectangle whose length is 5 feet more than its width. What is the area of the rectangle when its width is 9? Don't pay attention to this part yet, because that's the kind of evaluating part. Let's figure out this part. Whose length is 5 feet more than its width. Well, let's kind of use that pseudo math that we were talking about earlier. So my length, I'm going to call that L. And L equals, because that's 5 feet more than. Now remember, more than is one of those flip-flop ones. So I'm going to do 5 plus, but remember we're going to flip-flop, more than its width, which I'm going to call W. So basically L equals W plus 5, right? Because I'm going to flip-flop, remember, because the more than. How do you find the area of a rectangle, though? Area equals length times width, right? So if I know my L is W plus 5, I can take W plus 5 and plug it into there. So then I can find the area of my rectangle. So I'm going to get area equals W plus 5 times W. Something like that, right? So that's my function rule. Let's figure out if the width is 9, what are we going to get? So I'm going to get area equals 9 plus 5 times 9, or 14 times 9, which is 126 feet squared. And that's the end of this video. See you later, Sabers!